This is the solution video for exam 2, problem 7. And here we're designing a state diagram with one input W and one output variable Z, just to throw things off so X is not the input variable. Anyways, the state machine outputs 1. If the following three conditions are satisfied, so all three of these need to be true at the same time, the current input is 0. So this means melee machine. We have to do a melee machine. No choice. Almost. The number of input zeros, since the most recent input 1 is odd. So basically here we're going to do an odd, even, odd, even, odd, even, based on the number of input zeros we've had since the most recent 1. And the total number of input 1s so far is odd. So we're going to need to figure this out. So draw the state diagram. Be sure to label your states, state transitions, and start state clearly. Solutions with more than 10 states are unacceptable. So basically we need one state, which basically is saying the number input 1 so far is even. Because if this is even, it doesn't matter how many input zeros we've had since the last 1. So we're going to have state A, which is A is number of input 1s so far is even. And so, if we get a 0 in this state, who gives a darn? 0, 0. We still have an even number of 1s, and therefore we can't satisfy condition number 2. If we get another 1, though, we're going to go into state B, which is the number of input 1s so far is odd, and since 0 is an even number, we're going to assume that just like we've always done in the past, and the number of input zeros since the most recent input 1 is even. And C, so we're going to do state B. This is 1/0. So now in C, number of input 1s so far is odd, and the number of input zeros since the most recent input 1 is odd. So that's the other possibility. So if I get a 0 while in this state, I'm going to go up to state C. So 0, and I'm going to think about my output. So I'm going to have an odd number of input zeros, and the current input bit is 0, so this should output a 1. Yeah, there's two possibility ways of kind of interpreting this. This is the way I'm going to interpret this. And if I get a 1, I'm going to go back to here. So now my number of 1s is even. And then when I'm in this state, and I get a 0, I'm going to go back to here, and output a 0. And if I get a 1, I go back to here, and output a 0. And that actually completes my diagram, except I need to choose a start state. And so if I haven't seen any 1s so far, I'm going to have even number of 1s. So this is my start state, and I have W/Z. And so now I've labeled everything, I believe. And so the question is, can I implement the circuit using window and the input The answer is no. Why or why not? We can have infinite zeros. Well, we really can't keep track of even or number. We need to keep track of the number of zeros. So we need to keep track of the number of zeros and whether that number is odd or even. But to do that with window on input, we would need potentially an infinite number of registers or flip-flops. Because we need to keep track of all of the odds and evens, or all of it, and then XOR all those together to find out if it's odd or even. And we can't, because we can't keep track of just information of is it odd or is it even in a window on the input.